college that we say every time we say Jai Hind.
Okay.
But the students say to teachers Jai Hind in the class. When we go, they say Jai Hind ma'am, Jai Hind sir, like that.
Oh, very nice.
Yeah, very good tradition here.
Very nice.
Always we are.
We have to say Jai Hind. We are
Yes, of
proud of
course.
Jai Hind.
Jai Hind ma'am and Jai Hind sir, like that.
Oh, very nice. Very good
It's
culture actually.
yes, of course, ma'am.
Mhm.
So I
Tomorrow
will start
here.
my presentation by with Jai Hind.
No, really. We should say. We must say.
Yes.
So here in Karnataka, voting is there. So tomorrow
Okay.
is holiday. Mm.
Yeah, here also in
Oh,
Ghaziabad
tomorrow?
also. Yeah, in Ghaziabad also there is a yeah voting.
Tomorrow?
Yes, tomorrow 26th.
Okay. So I think people will join another 2 minutes. So we are starting always timely by 2 o'clock, and slowly, gradually, all the people are joining.
Okay.
So you have taken some few student to guide the project. Your own topic you have given to your student.
Uh, yeah, ma'am. Actually, that they are doing. Actually, myself is working for some patent regarding the topic, and also the students are also working. I'm guiding them for designing over quantum dot and all the electron circuit if they can design. So that's
Good.
yeah,
Good work should always be in progress.
yeah.
This is always good.
Uh,
Okay, Asha madam.
Yes, ma'am.
Yeah. So 2 o'clock, formal way of by introducing the speaker, you can start the session. Okay.
Sure.
Let people should join gradually. So you can start.
Now people are joining in. Shall we
Amita,
start?
put your yeah. You start. Amita, put your first slide.
okay.
Yeah, you start.
Yes.
Is it visible, ma'am?
No,
It's not
Asha.
visible.
Actually,
Yes,
you
ma'am.
have you have allowed her to share the screen. Now it is visible.
Now it's visible, ma'am. It's visible.
Hmm. Visible. Visible. Okay. So with this screen,
Hmm.
this is correct. Asha, now you can start.
Yes, ma'am.
And few people will be there in the camera. You can take the snapshot.
Yes, ma'am.
Okay, start Asha.
Good afternoon, ladies and gentlemen. I, Professor Asha, Department of CSE, welcome you all to the afternoon session of 9th day of Faculty Development Program on Quantum Computing and Sensor Technologies. It is my great pleasure to introduce our esteemed speaker for today's Faculty Development Program, Dr. Amita Asthana. Dr. Asthana's impressive credentials speak volumes about her dedication to academia and research. As an associate professor at Ajay Kumar Garg University College in Ghaziabad, she has continuously demonstrated her passion for advancing knowledge in the field of electronics and communication. With a PhD from Amity University and a solid academic foundation, including a BTech from Dr. Bhimrao Ambedkar University and a Master of Technology from Abdul Kalam Technical University. Dr. Asthana's expertise is both broad and deep. Her research interest, which encompasses optical cross-connects, digital cross-connect implementation, CMOS and quantum dot cellular automata software circuits, nano quantum circuits, and design of optical orthogonal ports are at the forefront of technological innovation in communication networks. Today, we have the privilege of learning from Dr. AmitaAsthana's wealth of knowledge and experience. Her insights promise to enrich our understanding and inspire us in our own pursuits of academic excellence. Please join me in extending a warm welcome to Dr. Amita Asthana. We eagerly anticipate your enlightening presentation and look forward to the valuable insight you will share with us today, ma'am. Over to you.
Uh, Thank you so much for inviting to the uh, to this conference, Advancement in Quantum Computing and Sensor Technology for Viksit Bharat at the rate 2047. And I would like to thank Dr. Preeta Shran ma'am for giving me this particular opportunity so that I can share few of my research to all of you. And so much thanks to all the listeners and all the convener of this particular talk. So here uh, I would like to present a talk on quantum dot cellular automata, in which we will discuss for designing the N cross N digital cross connect switch architecture. So basically, the designing is software, and where we would be designing for the N cross N users at the sending side and N users at the receiving side. So here the presentation outline would be: first I will be giving the introduction for the digital cross connect and what we are going to do in this particular research work. And then we will design a small switch unit, that is digital cross connect switch element, using two users at sending side as well as on the receiving side. And using considering this particular 2 cross 2 architecture, we will extend the designing up to the N cross N Clos switch matrix. Here Clos network is a multi-stage switch matrix where we are going to design this using only quantum circuit. That is, we will be designing the circuit on the QCA software. Um, since not only the switch architecture is necessary here for the designing, but yes, we should be designing some basic parts for calculation, uh, or some the scheduling, for the scheduling not only the switch architecture but the scheduling and routing of the data, as well as the MAC architecture for some computation. Although all these circuits we would be designing using QC only. Um, then extending this particular talk to the novel reversible latches designing, where since the flip-flops and the combinational circuit are the basic units for designing any particular digital switch architecture, so we will see if we can design our switch architecture using reversible latches. And then finally we will have the conclusion and the future scope for the work, and then coming to the references. So here we start the designing of the router switch using quantum dot cellular automata. Now coming to the introduction, this digital cross connect switch architecture can be designed with a very less area. Here we are interested in designing the circuit using quantum technology, and quantum technology is all about we are here to work to make the circuit in a very less area and with a very low power consumption. This is the basic idea behind designing any quantum circuit for whether it's a quantum computing part or whether it's a designing. So here the cross connect switch architecture can be designed with very less area. There are so much modules which are employed for designing any switch architecture at the router. So here all the modules should be designed, and they should be considered and compared with the standard result. The quantum level design is also verified by calculating its delay and the energy consumption of the circuit. And here these particular parameters needs to be considered. Now the quantum level circuit realization of any combinational or sequential circuit, whenever we are designing any quantum dot cellular automata circuit, it is requiring the clocking of the circuit in basically 4 zones, and this is the basic requirement of any quantum circuit which we are designing. The first zone is switch, then hold, release, and relax. Now all these cells in any quantum dot are clocked separately by these 4 clock zones for the proper propagation of the data. Basically, here the major part of concern is since all the propagation of data is done by the various clock zones, so it is difficult to design, and it is also challenging to design any circuit with to provide them a different clock zone. But we can do if we can have a circuit like if we can do a proper sectioning